Hi, ladies and gentlemen. Welcome to another grade 9 science video. This one is on two different properties of electricity, electric current and electric voltage. Um, we can describe electricity using a variety of different words. These are two of them. So let's take a look. So electric current is a measure of the number of electrons flowing past a point in a circuit. So it's how many electrons are flowing in a circuit. It's a measure of that. It's measured in amps or amperes, and the unit is A. The unit symbol is A. We're going to use current in mathematical equations in a few days, and when we do that, the symbol in equations is I. Okay, you can think of electric current like the volume of water coming out of a tap. So you can imagine a high volume flow of water or a low volume flow of water. A high volume flow of water can do more work than a low volume flow of water. So you can imagine if you're trying to wash your hands, you can wash your hands more quickly with a high volume flow of water than you can with a low volume flow of water. Let's take a look at how to measure electric current. Right here we have an ammeter. An ammeter measures the number of electrons passing a point in a circuit, and so you have to put it in series. You have to put an ammeter in series in a circuit, and you can see this is a screen capture of the PhET simulation that you'll be working on shortly. Um, this is an ammeter, and you can see how it is in series. So it is capturing all the electrons that are going through the circuit at that point, and we want to measure all the electrons in this circuit here. Okay, here's the symbol. We learned about circuit symbols yesterday. This is a symbol for an ammeter, so it's a capital A in a circle. And this is another form of ammeter in the simulation that you're going to do soon. If you wanted to measure the current in this portion of the circuit, you could simply drag this little device over here. It's kind of magical, but it works certainly with an electronic simulation. Have to be careful with current. In your home, if too much current passes through a circuit, it can overheat the system and you can get a house fire. We don't want to overload a circuit. In a few days, we're going to look at some home safety issues with electricity. And we have in our homes things called circuit breakers, ground fault interrupters, and fuses. And all of these protect us from overloading a circuit and drawing too much current. The other thing we have to be careful about is our bodies are very sensitive to electrical current, and you can feel 0.05 amps of current. It's a tingly feeling. And if we get up to 1.0, 4.3 amps, we have to be very careful if it goes through your chest because that can actually stop your heart. So we have to be very careful about that. Let's move on now and let's take a look at electric potential or voltage. So another way to measure electricity is what's called volts or electric potential. And it's a measure of the energy that electrons carry in the circuit. So it's how many joules or how much energy electrons are carrying. And it's measured in volts, and the unit is V, and the symbol in equations is also V. And we can think of electric potential like the pressure of water coming out of a tap. So if you have very low pressure, you can't get a lot of work done with that water. It's hard to wash your hands with it. Where if you have high pressure, you can get a lot of work done. Sometimes I like to think about current and voltage in terms of bees. And the current, if you had um, a lot of current, you would have a lot of individual bees buzzing around. And electric potential, you could think about how angry the bees are. So you can use metaphors like water, or you can also look at things like bees to analyze differences between voltage and current. When we measure electric potential, we have to make sure that we connect a voltmeter correctly. So electric potential is measured by a voltmeter. Here's one that you would find at home. It's very handy to have to make sure that batteries are charged and circuits are working. The symbol for a voltmeter is a V in a circle, And as you can see from a screen capture here of the simulation that you'll soon be working on, it's important that we connect a voltmeter in parallel. Okay, so the voltmeters are always connected in parallel. You'll remember from current, and you can go back and check, we had to put the ammeter in series. In this case, we are putting the voltmeter right here in parallel. So what that means is that we're testing right here, we're testing the energy that electrons have before the light bulb, and then we're testing the energy that electrons have after the light bulb. And so we're testing two spots in the circuit, and that's why we say it's connected in parallel, because there's a parallel circuit with this voltmeter. Let's talk about a little bit of electric potential terminology. And various electrical components change the energy that electrons are carrying. So things like a light bulb or a resistor use energy in a circuit, and they lower the electrical potential in that circuit. Therefore, voltage drops across a light bulb. Also, components like cells and batteries and power supplies increase energy in the and raise the electrical potential in the circuit, and therefore we say that voltage increases across a battery. So if we were to go back here and we were to look and take our voltmeter and we were to connect it here and we were to connect it here, we would say that there was a 9-volt drop across the light bulb. If, on the other hand, we were to take the same voltmeter and connect it across this battery, we would say that there was a 9-volt rise across the battery. So that's a quick introduction to electric current and electric potential. I hope you enjoyed it. You can progress now to the simulation where you're going to measure both of those in a circuit.